Is for MAT1033 Intermediate Algebra, Chapter 7, Section 4. This is example 2, which is the addition and subtraction of radicals. Again, I don't want you to do any kind of problems with fourth root or fifth roots. So this is a square root. We have the square root of 20 plus 2 square root of 45. We know that we need to know our perfect squares, because a perfect square has to divide into these numbers. Otherwise, we can't reduce the radical. So 20 becomes 4 times 5. Notice that 4 times 5 is still 20. 45 becomes 9 times 5. And what happens is the square root of 4 becomes 2, which comes outside. The 5 stays inside. Square root of 9 becomes 3. When it comes outside, it multiplies times any numbers outside. So it becomes 6 square root of 5. The rules for addition and subtraction of radicals is not only must I have the same radical, meaning square root to square root, cube root to cube root, but I must have the same irreducible value inside. Here I have 5. This is just like, you got to look at this in terms of like 2x plus 6x. The x's make it like terms, so we just add the 2 and the 6 and get 8. In this case, we're dealing with radicals, so it becomes 2 square root of 5 plus 6 square root of 5, which is 8 square root of 5. Second problem here deals with cube roots. And we got to know our perfect cubes. We got to know that 8 is a perfect cube. 27 is a perfect cube. 64 is a perfect cube. 125 is a perfect cube. So what happens here is we go through the same thing. 54 becomes 27 times 2 because 27 is a perfect cube. 16 becomes 8 times 2 because it's a perfect cube. And of course this is irreducible. Cube root of 27 is 3, so it comes outside as 3 cube root of 2. Cube root of 8 is 2. It comes outside, multiplies times 5, so it becomes 10 cube root of 2. And this, of course, is 1 cube root of 2. I could even actually take this and put a 1 right here if I wanted to. And that would still mean the same thing. So what I did here was collect like terms. So 3, a positive 3, and a positive 1 cube root of 2. Makes it 4 cube root of 2 minus 10 cube root of 2, which gives me negative 6 cube root of 2. The last example problem here, we have cube root of 98 plus square root of 98. Right now we can see that we can't add them because we got a cube root plus a square root. Remember, when you add and subtract radicals, they must be the same radical. Square root to square root, cube root to cube root. What we can do here is we can't simplify 98 because there is no perfect cube that divides into 98. So it's going to remain the same. But we can take 98 square root and make it 49 times 2. Square root of 49 is 7. So it becomes cube root of 98 plus 7 square root of 2. Remember, when you're dealing with radicals, it's like fractions. You're not going to see any directions that say reduce radicals. It's understood that you reduce radicals. This is example 3 on page 443. This deals again with addition and subtraction of radicals, but this is dealing with fractions. So you've got to know your rules for fractions, and least common denominator, and so on and so forth. So we'll go through the same process. Square root of 45 can be reduced to 9 times 5. This is irreducible, so it just carries down. Square root of 9 is 3. The 3 comes outside, so now we have 3 square root of 5 over 4 minus square root of 5 over 3. Then what we can do, so then what happens here is that we have to, if we want to subtract these two, we have to get least common denominator. Least common denominator between 4 and 3 is 12. So here we're going to multiply by 4 over 4, and we get 4 squared root of 5 over 12. Here we're going to multiply by 3 over 3, gives us 9 square root of 5 over 12. 9 square root of 5 over 12 minus 4 square root of 5 over 12 gives us 5 square root of 5 over 12. We come over here to the second one. You notice that we have cube root of 7x over 8. And so this is a problem where we're going to write them separately. We're going to write cube root of 7x over cube root of 8. Notice I also put the 2 cube root of 7x over 1 because I'm really trying to add two fractions. Cube root of 8 is 2, so now I have cube root of 7x over 2 plus 2 cube root 7x over 1. Again, we got to find least common denominator, which the least common denominator between these two is 2. So we multiply top and bottom by 2 over 2. That now gives us 1 cube root 7x over 2 plus 4 cube root of 7x over 2. Going to keep the 2 on the bottom, add the 4 and the 1, we get 5 cube root 7x over 2. And the last set of example problems here, this is example problem 4. And this is multiplication, which we covered before spring break. But just to refresh your memory, this is a binomial times a binomial. Same thing that we've done all before. So I'm going to go square root of 5 times square root of 7, which gives me square root of 35. Remember, it's the outside, which is a 1, times the outside, which is a 1. That gives me a 1 here. And it's inside times inside. So when I'm multiplying radicals, remember, outside times outside, inside times inside. I go square root of 5 times 1, which gives me a plus square root of 5. I go a minus square root of 6 times square root of 72, which gives me minus square root of 42. And I go minus square root of 6 times 1, which gives me minus square root of 6. Now, normally in these problems, I would look here to see if I could reduce this. Is there a perfect square that goes into 35? No. Irreducible. Already in simplest form. Is there a perfect square that goes into 42? No. Irreducible. Simplest term. So this is my answer. I can't simplify it anymore. Come over here, and you should recognize this as what we call a difference of squares. Same first term in both sets of parentheses, opposite signs, same last term. Which means I really don't have to take care of the middle. Because if I do this times this, I get a 5 square root of 2x. If I do this, I get a minus 5 square root of 2x. They cancel out. So really I have to do is go this times this, which gives me square root of 4x squared. Minus 5 times a positive 5 gives me minus 25. Square root of 4 is 2. Square root of x squared is x. 2x minus 25.